Eventually, that leads us to having better estimations of risks for our customers, which is really what we want. So I am Ferdy. I'm currently the team lead for the 3D layers team. So basically we're responsible for what we call the 3D layers, which is the height information being used by the company. When it comes to our main product, which is vegetation risk management, there are a couple of variables that are going into this, like the health of the vegetation, the species of the vegetation. Height is one of the integral parts of this risk. How tall a piece of vegetation is relative to the infrastructure that we're monitoring is a very important part of the risk calculation. So the problem we were facing is that we were getting incorrect calculations of height, which of course is a big problem for us. We never want our customers to go out in the field and find that something is substantially different from what we predicted. When we're doing depth estimation and stereometry, we're effectively asking, where is this object in this image versus where is it in the second image? And by being able to calculate how much this object has moved from image A to image B, we can infer how far away from our camera this object was, and from that we can infer depth. It wasn't until we really started looking deeply at how the algorithms that we're using were working that we realized that, oh, okay, these algorithms were just not understanding which objects were objects in one image and which objects they corresponded to in the second image. That's where we really saw that, okay, there's a way we can improve this. So quite recently in the field of stereo vision, deep learning algorithms have been making big strides, as in most of computer vision. And the big advantage you have with deep learning over traditional methods is that deep learning has a better understanding of what an actual object is. How deep learning roughly works is you show the algorithm a lot of examples of the problem you're trying to solve with the solution, and then the neural network will learn weights that solve this problem. But yeah, there's quite a big step there, is where do you get this training data? Because it's not just trivially available. That was actually one of the biggest challenges in making this product work, finding the training data and putting it in such a form that we can actually use it to train an algorithm. So yeah, after quite a bit of work, putting everything into the correct format, we were able to train our deep learning algorithms to the point where we could get height estimations that were competitive with LiDAR and that were much better at detecting trees than what we were using before. I think eventually what we ended up using was about 1,000 square kilometers worth of data. We put in quite a lot of work in actually building a nice pipeline to actually do these calculations and to really automate the whole process, and in such a way orchestrate the work that a job that previously would have taken 8 hours for a set of stereo images could now be run in about 30 minutes. So yeah, just in terms of the time saving from our perspective, it was a pretty huge time saving. Eventually that leads us to having better estimations of risks for our customers, which is really what we want.